Hi guys, let's understand what is EFK stack. EFK stack is collection of 3 open source products. One is Elasticsearch, second one is Fluentd, and the third one is Kibana. These 3 products are used to monitor logs of our application. Now here I am having one application in my local. So this is one Spring Boot application. Let me run this Spring Boot application in the local and let me show you how the logs will be printed. So this is my local. I'm running my boot application. The boot application will have the embedded Tomcat server with port number 8080. Yeah, application started. You can see the messages are printing on the console. Clear the console, go to browser and access this application. Localhost colon 8080. So when I hit that URL, you can see my application is accessible here. And I'm trying to insert some record in my application. Click on submit. After inserting the record, I want to see the records which are available in our application. View all products. Now you can see the products are displaying. Now here, click on add new product, add one more product, price and quantity. Submit. Product got saved. View products here. The products which I have added, they are displaying. Like this, users will interact with our application. So when application is executing, application will generate some log messages like this. You can see here, which page, product saved, product view page loaded, product saved, product view page loaded like this. What happened in the application that is printing on the console, this is called logging. For every application, logging is very important. Logging will help us to understand the execution flow of the application. If any problem occurs in the application, developers can see the log messages and they can identify the problem and they can fix the problem. Fine. Currently application running in my local machine, so I'm able to see the log messages. What if application is running in my Kubernetes cluster? If I deploy my application into Kubernetes cluster, then how to monitor the logs of the application? So that's where we are going to use this EFK stack. EFK stands for Elasticsearch, Fluentd, and Kibana. This EFK stack provides centralized logging in order to identify problems with the servers or applications. So whatever the logs that you want to monitor, you can monitor them by using this EFK stack, right? This EFK stack will allow you to search for all the application logs in the single place with a beautiful user interface. Elasticsearch is used for storing the logs, that is called log lake. Fluentd is going to collect the logs from the nodes and will store into Elasticsearch. And Kibana is a visualization tool to monitor logs of our application. Let us see architecture of our EFK. Now here, our applications will execute as pods in the multiple nodes. So every pod will generate some logs. So those logs we will collect by using Fluentd. Fluentd will give the logs to Elasticsearch. Elasticsearch is going to store the logs. Then Elasticsearch will give the logs to Kibana. Kibana will provide one beautiful UI, user interface. We can connect with the Kibana UI and we can search for the logs of our application. In order to do this, first let me deploy my application on the Kubernetes cluster. Okay, now here my project is available in the GitHub repository. Here I have cloned that GitHub repository Spring Boot Timeleaf application. So if we go inside that application, whatever the application I have shown you in the local, now this is my local URL. Now I will run this application in the Kubernetes cluster. So here Spring Boot Timeleaf application is available. So if you see ls-l, for this application, Docker file is available and deployment file is also available. I have created Docker image also for this application and I pushed into Docker Hub. So let me go for id.dockerhub.com. Right, go to Docker Hub and search for our Docker image. So Spring Boot Logger application I have created and I have created a Docker image also for that. So here you can see SB Logger app is available. Yesterday I have pushed this image into my Docker Hub. Now by using that Docker image, now I am going to create the deployment. Here my deployment.yml file is available. So you can see deployment.yml. This project will be deployed as pod, and I'm going to expose that as a service. Load balancer service is available. I'm creating the pod for that, and I am creating the service to expose the pod as a load balancer. So this will be created under a custom namespace called Ashok IT namespace. So load balancer is the service type I'm giving for that. Ashok IT NS is the namespace. Now let me create the deployment. kubectl apply -f deployment.yml. So I'm trying to create the deployment by using this deployment.yml. Now you can see here, namespace got created, my pod got created, and that pod is exposed as a service also. So they have created under custom namespace. So let us verify that. kubectl get pods -n Ashok IT namespace. The pod is created. You can see 1 out of 1. The pod is in the running status. Now, similarly, let us get the service of that. kubectl get service -n Ashok IT namespace. My service is also created. This is my Java web application service. The type is load balancer, and this is the load balancer URL. So within the cluster, it is running on 30321 port number, and for outside, it is 80. Using this load balancer URL, we can access our application. So access this load balancer URL, take this load balancer URL, and access that application from browser. Type this URL, now enter. So let's see here. Our application is accessible. Yes, the application is running in the AWS, in the Kubernetes cluster, EKS cluster. In that application, I deployed my project, and I'm able to access that project using load balancer URL. Now, view all products. So currently, no records available in this application. We have not inserted anything. Add a new product, product name, price, and quantity. Submit. View products. Now, one record is inserted. Click on add product and select here quantity and price. Submit. So view products. So I inserted keyboard and mouse records. Now here I want to see the logs of this application in the cluster. So we already discussed how to check the logs in the cluster. To check the logs in the cluster, we have kubectl logs command. First, let me get the pods -n Ashok IT namespace. So kubectl get pods which belongs to this namespace. So this is my pod name. Now I want to access logs of this pod. So in general, to access the logs of our pod, kubectl logs pod name and namespace. So this is my pod. This pod is available under this namespace. Now like this, we can get the logs of our application. You can see product view page loaded, product saved, product view page loaded, product saved, product view page loaded. So 2 products I have saved. Those log messages are printing by my application. So right here, we are able to monitor the logs by using kubectl logs. We are able to access our Kubernetes cluster. We connected to control plane by using kubectl, and we are getting the logs by using this kubectl logs command. Then what about the developers? Are we going to provide the cluster access for the developer to see the logs of the application? No, we should not do that. Then how developers will monitor logs of the application to understand the problem? That's where EFK architecture comes into picture. As a DevOps engineer, we have the access for our cluster. We have the access to get the logs of the pods by using kubectl logs, pod name, and namespace. I'm able to see the logs. Then how developers will monitor logs of this application? How developers will monitor logs of this application? So that's where we need to provide one platform for the developers to monitor logs of the application. That's where EFK architecture comes into picture. EFK, E stands for Elasticsearch, F stands for FluentD, K stands for Kibana. FluentD will be deployed on the each worker node as a daemon set. So what is a daemon set? Daemon set is used to create the copy of the pod on the each worker node. In my cluster, two worker nodes are available. So in the two worker nodes, I can create the pods. Then to collect the logs from the two worker nodes, I will deploy FluentD as a daemon set. Then Elasticsearch. Elasticsearch is used to store the logs. So I need to make this as a stateful container. For that, we will go for stateful set. Elasticsearch will be deployed as a stateful set. Kibana is a front-end application. I'm going to deploy this by using deployment resource. FluentD, Elasticsearch, Kibana. FluentD will collect the logs from the worker node pods, will give it to Elasticsearch. Elasticsearch will store the logs and will index the logs. Kibana will provide the UI. Using Kibana, we can get the logs available in the Elasticsearch. Now, we need to deploy this EFK architecture. So like this, you can see the Kubernetes cluster components will be available. FluentD will collect the logs, will give it to Elasticsearch. Elasticsearch will maintain a persistent volume to store the logs as a stateful set we are going to deploy. Then it will give the logs to the Kibana. Kibana will provide one user interface like this to monitor logs of our application. Now, let me set that EFK setup. Let me set up that EFK in our Kubernetes cluster. To do that setup, I'm using manifest files here. I have uploaded those manifest files in our GitHub repository. So if you go to our repository, you can check Kubernetes manifest YML files. I have shared in our group as well, the Git repository link. In that, I have created a new directory that is called EFK log directory. In that EFK log directory, we are having required manifest files to set up our EFK in the cluster. Now, so first one is namespace YML. So this is going to create a namespace. EFK log namespace will be created. Once the namespace is created, then Elasticsearch service and Elasticsearch will be created as a stateful set. Then FluentD config map will be created. Then FluentD will be deployed as a daemon set. Then Kibana will be deployed as a deployment. Kibana will be exposed as a load balancer service. So these manifest files you can find in our GitHub repository as well. So if you go to our GitHub, here you can check Kubernetes manifest YMLs. In these manifest YMLs, EFK log is available. I cloned this GitHub repository in this Linux machine. These are the files that are available in that directory. Now go to here, EFK log directory. Here I have given namespace YML. This EFK pod services I want to create under one namespace called EFK log namespace. My application is running under Ashok IT namespace, and here EFK will be running under EFK log namespace. Now that is for namespace. This is Elasticsearch YML. For Elasticsearch, first I am creating a service here. That service, we are going to expose the pods, right? So this service is for Elasticsearch. Elasticsearch we don't access outside. And remember, Elasticsearch will be running on the port number 9200. Then Elasticsearch is stateful set. So here for Elasticsearch, RBAC account should be created, cluster role bindings are required, and Elasticsearch will be deployed as a stateful set, right? It will maintain the value to maintain the data. Then after, FluentD will be available. FluentD will be deployed as a daemon set. Why we are going for daemon set here? I want to create the FluentD on all the worker nodes to collect the logs from all the worker nodes. Once FluentD is completed, then Kibana will be deployed. Kibana will be deployed as a deployment approach. Then once it is done, Kibana service will be available. Kibana service, I'm going to give the type as a load balancer. Kibana will be running on the port number 5601. So finally, once this setup is completed, we are going to access Kibana outside the cluster to monitor the logs. All right. Now here, these YML files are available. You can apply these YML files one by one, or you can apply all the files at a time. So I have given the order also. Total 7 files are available. One after other we need to apply. For that we can go for kubectl apply -f, the first one namespace YML. Like this you can apply, or if you give dot, then all the files will be applied. Kubectl apply -f space dot, then all these files will be applied. Now, sorry, spelling mistake in the command. Kubectl apply space -f space dot. So when I do this, namespace is created, Elasticsearch service is created, cluster rules are created, right? Daemon set is created, deployment for Kibana is created, Kibana service also created. Once these are created, let us check the pods which are created under this namespace. Kubectl get pods -n efk log. So in this namespace, now you can see Elasticsearch pods 30 seconds ago, Elasticsearch pods created and FluentD pods created and Kibana pod is also created. Let us get the pods which are available under our namespace, Ashokite namespace. Spring Boot application pod is running in the Ashokite namespace. EFK related pods are running on the EFK log namespace. Two different namespaces are available. Let us get the service here. Kubectl get service -n efk log. So here if you observe, Kibana is logging. Elasticsearch is running as a cluster IP. Here IP address is none. That is a headless service stateful set that will run on the port number 9200. And here my Kibana pod is running as a load balancer, and this is the load balancer URL. If you see this load balancer URL, the port number is 5601. So that is the default port number which is using by our Kibana. So it is a load balancer URL. Now go to our AWS EC2, load balancer will be available. You check the load balancer which is created. Now the load balancer is created. For application, one load balancer is created, and for Kibana, one load balancer is created. Now this is Kibana load balancer URL. So go to this load balancer, go to the security group, and enable 5601 port number, because Kibana is running as a load balancer. Kibana is using port number 5601. Go to the load balancer security group, edit the inbound rules. Here we need to enable a port number 5601. So in my scenario, it is already configured 5601. Save the rule. Once it is done, now let us try to access our EFK structure in the browser. So take this URL of Kibana, copy this URL, go to browser, port number :5601. So with this, we should be able to access our Kibana dashboard. So I'm able to access my Kibana dashboard. So here application can be accessed and Kibana also can be accessed. Both are running in the cluster. Once you access the Kibana, now here you can click on explore on my own. Click on explore on my own. Once you click on that, now go here. There is an option called discover. Click on the discover, and we need to create index pattern to monitor logs of our application. We need to use index pattern to monitor our application. In this index pattern, just type star. That's it. Once you type the star, it will give you the log stash. Select this. Now, just to type the star in the index pattern, go for next step. So once you go for the next step, it is asking configure settings to filter your field. Select @timestamp here and click on create index pattern. So with this, I have created my index pattern to monitor my application logs using Kibana. Again, after creating this index pattern, go to discover. Then here you will get the option to search logs of your application. Now it is loading the logs. Now these are the logs that is displaying. These are our cluster logs. Kubernetes related logs are coming here. Now let me access my application. kubectl get service Ashok IT namespace. Here, this is my application load balancer URL. Take this URL. Port number is 80, so no need to use it. Directly you can access the application. This is my application URL. Now view products available. 2 products we inserted. Let me add one more product. Let me add hard disk. Product price 4,500. Quantity 2. Click on submit. So now name should have minimum 3 and maximum 15 characters. Hard disk. Okay. Click on submit. Product saved. View all products. 3 products are available. Now I want to monitor these logs. Refresh. Now let us check the product application I have accessed. The product logs are available in this Kibana or not. Let us search with a name called product here. Click on enter. Now you can see. So here just now product view page loaded. It is giving the date and the timestamp also when this log message got generated. 7:38. So just now this log message is generated. So product view page loaded, product got saved, product form validation failed. So when I submit the product with the 2 characters, my product form validation got failed. That message also displaying in the Kibana. Product view page loaded, product view page loaded. So how many times we access our application generating the log messages? Those log messages we are able to access by using Kibana. So for the development team, we will give this Kibana dashboard URL. Developers will monitor the logs. Here you can monitor the logs based on the dates, and you can select the particular timestamp, only today logs, or last 15 minutes logs, last 1 hour logs, last 7 days, 90 days. Here you can select the timestamp, the duration for what you want to monitor the logs, right? Which logs you want to monitor, which date logs you want to monitor, which time period logs you want to monitor, that you can do by using this Kibana. So as a DevOps engineer, we will set up this EFK and we will give to the development team. Developers will use this Kibana dashboard to monitor the logs, and with these log messages, developers will understand what are the exceptions or what are the problems occurring in the application, and they will identify the problem, root cause, and they will fix the problem. So with this, we are able to set up EFK in the AWS EKS cluster, and we are able to monitor logs. So like this, the dashboard is going to provide the logs for us. Guys, are you clear with this? Are you guys clear with this? So you understand what is EFK? What is EFK architecture? Now, Fluentd is created. Fluentd is created as a stateful set that will be created on the each worker node. Then Elasticsearch is available and Kibana is available. Fluentd will collect the logs and will give it to the Elasticsearch. Elasticsearch will give the logs to the Kibana. Kibana is providing the UI. From that UI, we are able to monitor logs of our application. Yeah, the people who are having the doubts, you can ask me now.
Sir, if we have to grep errors, then how do we do it, sir?
Sorry?
If we have to grep only for errors, then how do we do it?
So you can type that error whenever the error occurred, right? Suppose if you type error. So if your log message contains error, if you click on that, then based on the error logs that you will get, see here, the dump an error event. So whatever the text that you type here, that text matches with which message, those messages will be displayed for you.
Okay.
So can you go to the architecture diagram?
Right.
So this is very clear that the microservices are running in 3 pods, and you have installed Fluentd in those worker set so that it grabs those and give it to Elasticsearch. But sir, in which worker node this Elasticsearch is running? It's not
Elasticsearch can run in the first worker node or can run in the second worker node. That is not important for us, right? So only important thing is Fluentd. Fluentd will be available in the both worker nodes. If you have 2 worker nodes, Fluentd will be installed in the 2 worker nodes and will capture the logs, will store in the Elasticsearch. Elasticsearch may run in the first worker node or may run in the second worker node. You can get that information in which worker node your Elasticsearch is running. kubectl get pods -o wide. So if you go with this -o wide namespace now, so here, sorry, EFK log namespace I want to give. So with this, you
can you do get all for on this? Yes. Want to see how many things are running in this namespace?
Yeah, you can see here.
EFK log.
kubectl get pods -o wide -n EFK log. So here Elasticsearch pods are running, and here Fluentd pods are running. Kibana is running. So Elasticsearch is a stateful set. For that, 2 pods are there, right? One is a primary pod, another one is a replica pod. So primary pod is running on the first worker node, replica pod is running on the second worker node. So 2 replicas they have given. And Fluentd, it is running in the first worker node and it is running in the second worker node because it is a daemon set. Kibana is a single pod. Kibana is running on the first worker node. So where the Elasticsearch is running, where the Kibana is running, that is not important for us because Fluentd should run in all the worker nodes. Fluentd should get the logs, should store in the Elasticsearch. Elasticsearch should give the logs to the Kibana. You got it?
Do we need to actually install this whole stack in each cluster, or can we have a cluster just for Kibana and Elasticsearch, and it can collect logs from all the different clusters?
Yeah, if you give that URL so that it can take that, but every cluster will have its own EFK setup because dev logs will be different, sit logs will be different, production logs will be different, right? So generally in every cluster, this setup will be done to monitor that environment logs. When the application is testing in the SIT environment, we need to monitor only SIT logs. When the application is running in the UAT, we will monitor UAT logs. When the application running in the production logs, we will monitor.
And you said Elasticsearch is stateful, but Kibana is not. Is that?
Yeah, Kibana is just a UI. Kibana is just UI.
It does not need to store anything.
No, Kibana will not store anything. Okay. Kibana will provide you this UI page. Whenever you search something, when you click on search, then Kibana will connect with the Elasticsearch, and from the Elasticsearch, it will get the logs and will display in the UI. That's it. Kibana is just a deployment concept. It is a web application. Elasticsearch is a stateful set which is going to maintain all your logs.
Okay, thank you.
Yeah. Ashok, yes. Can we say that this Kibana is just like Tableau or Power BI? Can we say that?
Yeah, it is a report. They are reporting tools, but here it is just UI based application.
Okay. And
I think it's very similar to Splunk.
The Tableau, ClickView, the Power BI, their functionality different. Kibana is just to display the logs which are stored in the Elasticsearch. That's
okay. So what would be the duration of the data that is saved in Kibana? Is there any specific?
No limit. No limit.
No limit. One more thing is like yesterday we have done the setup for ESK, right?
Yesterday's setup was with the Helm charts. With the Helm chart, we are facing the issue. That's why I am using the manifest YMLs to do that setup.
Okay, so can we follow the same thing in our like live
Yes,
project?
you can do that. You can do that. So here I have already uploaded these YML files to the GitHub repository under EFK log folder. You guys can clone that repository and you can try the same thing. And my application image also available in the Docker Hub. Image name is ashok-sb-logger-app. You can deploy that application. You can see this project.
Okay.
So whenever you do some operations on this project, the logs will be generated. Those logs we can monitor by using our Kibana. So if you type product and if you click on search, the recent log messages are coming at 7:46. Now the time is 7:46. At 7:46, I have loaded my products page. It is displaying that. So real-time logs we are getting. Suppose now the last log that we have at a 7:46, that is product view page loaded. Now I am going to create one more product. Create new product. Product name I am giving as RAM. Product price is 4,500. Quantity 25. Click on submit. Product save. Right now that log message I want to see. Go to Kibana. The last was product view page loaded. Now I'm typing the product here. And I'm clicking on refresh. That means I want to load the latest log. Now you can see at 7:47, it is printing product is saved. That log message is coming to the Kibana. So the real-time logs we can monitor by using this Kibana.
Sir, can you generate alerts also, sir, on this?
The alerts purpose, so not the Kibana, sir. Alerts purpose, we will use the Prometheus. In the Prometheus, you can create the alert. So here only we will do the logs monitoring for our application.
Sir, every time we need to refresh this page or it is auto updated?
No, you need to refresh this page. Generally, as a DevOps engineer, you will not monitor the logs. Your responsibility to set up this components and give the URL to the developer. Developers will monitor. Whenever there is a problem, they will check the issue, why the problem is coming, where the problem is coming, and they will fix that issue. They will commit the code. Then we need to redeploy our application.
What is the difference between Splunk and
Splunk? Yes, good question. Splunk is also will do the same thing, but Splunk will have more advanced features for the reports generation, dashboard creations and all. Splunk is a commercial software, whereas this EFK is a open source software. So if most of the companies will go for Splunk, that is a commercial software, very advanced reports, graphs that we can generate in the Splunk. Okay. This EFK is a open source, so limited features will be available.
The Nagios is also doing the same now.
Sorry?
Nagios is also doing the same thing.
Nagios is not for logs monitoring. Nagios is for application performance monitoring.
Okay.
Yeah, that is different.
So will you spend some time to go through the manifest files that you have created?
Yes, sir. These manifest files I have downloaded from the internet, sir. These manifest files I have downloaded from the internet. So for time being, what you need to keep in the mind is, so in these things, FluentD will be deployed as a daemon set. Elasticsearch will be deployed as a stateful set. Kibana will be deployed as a deployment. So this FluentD pods will be created on the each worker node as it is a daemon set. Elasticsearch running as a stateful set. 2 replicas are available. One master pod, primary pod will be created, and one replica pod will be created. So where the Elasticsearch is created, in which node it is creating, that is not important, because FluentD will install on all the worker nodes. It will get the logs, will give to the Elasticsearch. Kibana will be installed. Kibana also will connect to the Elasticsearch. Elasticsearch URL, and Elasticsearch will run with the 9200 port number as a cluster IP. So Kibana, Elasticsearch, FluentD, all the pods will run in the cluster. FluentD will give the data to the Elasticsearch. Kibana will fetch the data from the Elasticsearch. So all these three components, the pods, services, I have created under a custom namespace. My application pods running in one namespace. My EFK pods are running in the another namespace. Whatever the logs that generated by our pods, kubectl logs command, the logs will be taken by FluentD, will give to Elasticsearch. So whenever you access Kibana,
so you said that.
Yeah.
So you mentioned Elasticsearch is a stateful service, right? So there's a one primary and like one master and one slave, right?
Correct. You already I have shown you that.
At one point of time, only one is active, or the second one is just the
write operation will happen with the primary pod, and read operation will happen with the secondary pod. FluentD should write the data to the Elasticsearch, right? It will use primary pod to write that. Kibana should read the logs from the Elasticsearch. It will use the secondary pod. Both pods will work.
Okay.
Good.
Ashok, I have a question. Where is the configuration for Elasticsearch in FluentD? Like manifest file? Like
in the manifest files, they will give the URL of the Elasticsearch. So if you go for FluentD, so FluentD will be referring to the URL of the Elasticsearch.
Okay.
Yeah. So even in the Kibana also, that will have the URL of the Elasticsearch. If you go for Kibana deployment YML, so in the Kibana deployment YML, we are going to specify that Kibana should connect with the Elasticsearch. This is the Elasticsearch URL. They are passing that as an environment property. This is the URL of the Elasticsearch. It will run with the 9200. As Kibana should connect with the Elasticsearch, Kibana will refer the Elasticsearch URL. Similarly, the FluentD should connect with the Elasticsearch. FluentD is a daemon set. So FluentD also will point to Elasticsearch URL.
Okay, so that's the reason we are basically pulling the Elasticsearch pod, right? First one.
Correct.
I mean,
Correct.
we in order.
Correct. First Elasticsearch pod should be created because this Kibana and Fluentd pods should connect with the Elasticsearch first.
Okay, got it. Yeah, thank you.
Yeah, one question. In the Kibana, we have created the index file pattern as the time period, right? So can you explain? Yeah, timestamp. Can you explain a little bit on
Based on
some of the?
Yeah, index pattern generally will give as a star. So now, if you have multiple virtual machines to run that, VM based IP address based index patterns will be created. And when I give the star timestamp, I want to get all the logs available in the log file. I mean to say, whatever the logs that are generated in the pod, I want to get all the logs. And when I give the timestamp, time-based log, I want to monitor. That means particular time, at what time the log is generated, at what date the log is generated. We want to monitor all those logs. For that, I'm creating star pattern with the timestamp so that you can see at what time, at what date the logs are generated.
Yeah,
Timestamp now. Timestamp for 30 seconds. So here, when the logs are getting generated, so at this moment, how many log messages are generated? 735 5 log messages are generated. 738 4 messages are generated. And in this gap, no logs are available. Again, at the 47, 1 log message got generated, and here 1 log message got generated. Timestamp period made means at what time, how many logs are generated, we can get that. Instead of timestamp, you can go for the remaining fields also. ID based logs, index based logs, score based logs. These are the different fields that we can configure.
Okay, which one we use in the current market?
Timestamp.
Okay.
Yeah. So now I'm giving my application URL for you. You guys can access my application URL. And you can hit that URL. You can insert one message, guys. All of you insert one record. I will show you the logs of that.
Hi, Ashok.
Hello.
Yeah, for the new project setup, what are the properties we need to modify in the manifest files?
I did not get your point, sir.
See, suppose we want to set up a new cluster. In what are the properties we need to modify in the existing manifest files?
For cluster setup, why you need manifest files?
Not means cluster, for a EFK setup.
No need to modify anything. As it is, whatever the files are there, you can install in the cluster.
Okay, how many nodes are there? All the nodes it will install. Am I right?
Right. You no need to set up anything.
So real-time scenario, when you are actually installing it, will they give the the meeting conducted, and also will they give that
Sir, in the real time, everything will be documented, proper process we need to follow. So based on the given documents, we need to set up that.
Okay. Suppose they're giving actually how many clusters we want to run, how many parts, how many.
Everything will be decided by our project architecture team, and they will give the proper documentation. Based on that only we are going to set up. So it's not one person decision to install EFK in this cluster, not to install the EFK. How many worker nodes we have to create, how many control planes, how many clusters we have to run. We can't take the decision as a team member.
Yeah. Okay.
You will get all that information.
That time actually will I get that BRD document, everything along.
Everything will have a for everything document will be available.
Okay.
So this log4j, it will have log4j, right? It will read those log only, right? Or it will.
Yeah. Now see here, people have inserted the records. Now the records are inserted. So almost 49 records are inserted into this application. Now go to the log dashboard and search for that. Let us give product and click on search. Refresh that. Now you see how many logs are generated with that keyword. Product saved, product saved, product saved, product view page, product saved. So these all are the logs. When this log is generated, what time, what date, everything we are able to get it in the Kibana. Now you see, as you people accessed application at 7:46, so 24 logs, 39 logs, 18 logs, based on the timestamp it is giving me. So what log message is generated, how many log messages are generated. You are able to access the
EFK or ELK both were acting as the same?
Yes, sir. Both are same. Whenever you have large, both are from the different companies, Logstash and Fluentd. So instead of Logstash, I'm going for Fluentd. So Fluentd is the best suitable component when you are dealing with a large data set. If you have small data set, then you can go with the Logstash. When you have large data set, then you can go with the Fluentd.
And sir, earlier we have applied kubectl get pods, and sometime we have to apply kubectl top pods. So both are same or any difference between these commands?
No, man. Get pods will give you what all the pods which are running. Top pods will give you how much memory occupied by each pod. So top pods command is used along with the metrics server to understand how much memory used by our pods. Get pods will give you what all the pods are running, what is the status of the pods. Both are different.
Okay.
All right. So I hope you got the clarity. What is log monitoring? What is logging? What is log monitoring? And how to monitor the logs by using EFK, and how to set up EFK in our Kubernetes cluster. So can anyone tell me what is logging in the project, guys? What is logging in the project?
It is just storing the application execution details.
Yes, it is the process of storing application execution details. Why we need to store application execution details?
To monitor the logs of the application. If the application,
Yes.
down or something like that, we can monitor.
When the application is running, multiple users will access our application. When they're accessing our application, there is a chance of getting the issue. So developers should monitor that issue. Developers should fix that issue, and we need to deploy the latest code. So to monitor the log message, developer needs a platform. That's where we are going to provide this EFK. EFK is the combination of 3 products as we discussed: Elasticsearch, Fluentd, and Kibana. Fluentd is a daemon set which is used to capture the logs from the pods and store into Elasticsearch. Elasticsearch is a stateful set which is used to store the application logs. And Kibana is a UI application. Kibana will get the logs from the Elasticsearch and will display. When we see this architecture, you can understand. Then next, if you see here clearly, so here Kubernetes cluster, in the Kubernetes cluster, multiple nodes will be available. In node, multiple pods will run. From all the pods, we need to collect the logs. Every pod will generate the log. Log collector will be there. Log collector will give it to the Elasticsearch. Elasticsearch will store in the persistent value. Then Elasticsearch will give to the Kibana. Kibana will give the dashboard. Like this, we will get the dashboard. Using this dashboard, we can monitor logs. Now, I have shown you the live logs. You people accessed our application. So many people created records in the application. So all the records that you can see here, view products. Now, so these many records got inserted. Almost 67 records got inserted. So for all these 67 records, you performed some operation. You are adding the new products and you are able to view the products. So whenever you perform some operation, that log will be generated in the Kibana. So here I'm giving the product and I'm clicking on the refresh. When I do that refresh, you can see the real logs it is loading. How many times you inserted, how many times you accessed our page. With the timestamp, it is giving all the information. Now here in this period, many people accessed our application. So 7:55 to 8 o'clock, many people accessed our application. Peak count 39 people accessed it at a time at the 7:56 timestamp. So like this, you can get the timestamp based counts and you can see all the logs. Here we have the option to select the date and time for the particular period. If you want to monitor the logs, you can do like this. Got it? Fluentd
can you remind how to do?
Fluentd is a daemon set. Why Fluentd is a daemon set? You can check it. Which one is daemon set? Which one is a deployment? Which one is stateful set? kubectl get all -n EFK log. So EFK log is my namespace. You can see these are the pods which are running in this namespace, and these are the services which are running, and one daemon set is running, one deployment is running, one replica set is running, one stateful set is running. So here Elasticsearch pods, Fluentd pods, Kibana pods are available. 29 minutes ago, those pods are created and those pods are in the running state. And coming to the service, Elasticsearch service is available as a headless service, and Kibana service is available as a load balancer. So total here, 5 pods are running and 2 services are available. Kibana service exposed as a load balancer to access Kibana outside the cluster. Elasticsearch pods exposed as a node port, right? Now, sorry, cluster IP with a headless service. Then Fluentd is deployed as a daemon set. So why Fluentd is deployed as a daemon set? Fluentd should collect the logs from all the worker nodes. So daemon set is used to create a copy of the pod on the each worker node. So Fluentd is created as a daemon set, and deployment. Kibana logging is created as a deployment. Kibana is a web application. Whenever you create a deployment will internally use a replica set. And Elasticsearch is created as a stateful set because it has to remember the data. So that's why we are making it as a stateful container by using stateful set. You can check what are the components that are created by using this kubectl get all -n EFK log command, EFK log namespace. Under that namespace, what all created, you can get that.
Sir, quick question.
Yeah.
So it is clear that how to create this ELK artifact or the namespace and all that stuff. It is clear to me how to create this Kibana ELK stack. Can you remind me how you deploy? Yeah, how did you deploy the application which is generating this log?
First, I have deployed my application. First, I have deployed my application. Then I have deployed my EFK. Right. I will give the notes.
Where is the Git? Yeah. I mean, is there anything specific in the application that we need to tell that, these logs needs to be picked up by Fluentd? Okay.
EFK setup, guys. So first one, clone project git repo. So I have given my project repository also in the GitHub, or else my Docker image is available directly. So now you can do like this. So deploy Docker image by using Kubernetes, or else clone git repo. So whenever you clone the Git repository, you can access my Spring Boot application. In that application, I have implemented logging as well. Spring Boot time leaf application is available. Copy that code. This is my Git repository. Git to clone repository URL. You don't need to do any packaging here, guys. Already I have given deployment YML in this repository. So create Kubernetes deployment. Create Kubernetes deployment. So in this repository, already the YML file is available. kubectl apply -f deployment.yml. Once the deployment is created, you can get the pods by using kubectl. You can go for kubectl get pods -n Ashok IT namespace. These pods will be created under Ashok IT namespace. Once it is done, then get the service details, get the service, get service -n Ashok IT namespace. Now access application using load balancer URL. Access application using load balancer URL. You can see the load balancer URL once it is created with this service. Once it is done, then next one, you need to clone git repo URL for Kubernetes manifest files. So I have already given manifest files repository URL. Kubernetes manifest YML's repository is available. In this manifest YML, you can see that EFK log is available. Now, once you have cloned this, then create EFK deployment. Right. How can we do that EFK deployment? So you need to execute kubectl apply -f dot. Right. You need to navigate to the EFK log directory. Navigate to 04 EFK log directory. Once it is done, then you execute this. Once it is done, you can get the pods which are created under that directory. That is EFK log is the namespace I have given. EFK log, EFK log. Now access Kibana. For that, you need to enable enable 5601 in Kibana LBR security group. Kibana is creating as a load balancer service. That Kibana will use the port number 5601. We need to enable the Kibana port number in the security group of our load balancer. Once it is done, access Kibana URL in the browser. Access Kibana URL in browser. Perfect. So once you access that, create index pattern. Create index pattern by selecting star and then @ timestamp. Access logs from Kibana dashboard. That's it. So this is the process that I have done. So for the EFK setup, I have cloned my Git repository where my application is available. In that application, directly my deployment YML is available. You can just execute the deployment YML. You don't need to package and build the Docker image because my Docker image is already available in the Docker Hub. You can just take my Docker image and you can execute this file. Then application will be deployed. Once application is deployed, you can check the pods by using kubectl get pods -n associated namespace. My application pod will be created under this namespace. Service also will create in the namespace. By using service, we can check the load balancer URL of the application. Access application using load balancer URL. Access application using load balancer URL. Insert few records. Insert few records in the application. Then clone the Git repository URL for EFK manifest files. Right. In this repository, EFK manifest files are uploaded. Once you clone that repository, go to this directory, EFK log directory will be available. In the directory, you can see several files. Just you can execute all of them in single shot using kubectl apply -f dot. All the 7 files will be executed. Those are for the EFK. Once those files are executed, you can check the pods of them by using this namespace. You can get the service by using this namespace. So then Kibana load balancer URL will be available. To access that Kibana load balancer URL, you need to go to the load balancer of Kibana, enable the 5601 security group. Because the Kibana will run on the port number 5601, access the Kibana URL in the browser. Create index pattern by selecting star and then timestamp. Access the logs from the Kibana dashboard. This we are done. After practice is completed, as we are using load balancers, bill will be generated. So conclusion, so delete application deployment and Kibana deployment. So application deployment having a pod, Kibana also having the pod. So now if I want to delete all these pods, services and everything, instead of deploying one by one, let us delete, instead of deleting one by one, let us delete the namespace. Now, if you see kubectl get namespace, kubectl get ns. Now you see, so Ashok ID namespace is available for the application, EFK log namespace available for the EFK pods. Now I want to delete my application and I want to delete all the EFK related components also. For that, you can go for namespace deletion. So kubectl delete ns. I'm going to delete this Ashok ID namespace. And then I will delete EFK namespace. When I delete them, the complete application also will be deleted and EFK pods also will be deleted. So once finally after practice is completed, delete Ashok ID namespace and EFK log namespace. Got it? Yeah. So Ashok ID namespace is deleted. My application will not be accessible. So similarly, EFK namespace I'm going to delete, EFK log, so that all Fluentd, Kibana, Elasticsearch, everything will be deleted.
Ashok, in real time, only developers would have access to check this Kibana dashboard, or all DevOps engineer also would have access?
You are the one who will give the URL for them. As a DevOps engineer, you will give the URL. Okay.
And Ashok, one more question. Suppose we have two namespaces, and in one namespace is around 4 to 5 resources present. So is it possible to access the resources which is present in the first namespace by a second namespace?
Yes, you can do that. In the project setup, I will do that. Database pods will be in one namespace, application pods in one namespace. I will connect from application to database.
Okay.
Fine, guys. Yeah.
If there is any issue related to this URL access or something, do we need to take care of it?
Yes, you are responsible to set up the EFK. You need to make sure that setup is working as expected. Developers should be able to access the Kibana using the URL which you provided.
If there is any issue with the URL or something, we can recreate it, right?
Yes, you can do that.
Yeah.
Fine, guys. So with
one
this,
more time, can you show how to enable that 5601 port in the load balancer?
Yeah, I have deleted that, sir. Now my load balancer is not available.
Okay.
Yeah, you go to the load balancer, click on that. There will be a security group attached to that. In that security group, you need to go to inbound rule and you need to enable. We will upload the video. You can see that.
Okay, got it. Thank you.
Yeah, fine. Guys, please practice the EFK setup. So tomorrow we are going to work with auto scaling in the Kubernetes. Another important topic, how to enable auto scaling in the Kubernetes, how pods will be created automatically when the load is increased. That we are going to see in the tomorrow class. Thank you, guys.